Today, we're going to talk about cyber risks in manufacturing, specifically manufacturing, and how do we prevent and block attacks faster. With me today, let me tell you a little bit about Zage first. Zage Security is a ZTNA, Zero Trust Network Access, and Identity Access Management cybersecurity fabric mesh that is an overlay to your existing network. And we'll show you a little bit about how we think our solution provides a more preventative method of stopping attackers and also protecting your critical infrastructure. With me today, I have Michael Leonard. I'll let him do an introduction. My name is Guile Jewell. I'm Senior Director of Enterprise Accounts with Zage Security. I have over 25 years of manufacturing and industrial automation experience, including cybersecurity. I'm with Mike today, who's our technical guru, just as a commercial asset. If you have questions about commercially what we're seeing in the field, talking to the C-suite and others, I might be able to lend a little bit of insight. Michael?
Yeah, thank you. So as Guile mentioned, my name is Michael Leonard. I've been in the technology sector for over 20 years now. Got my start in the U.S. Air Force. And during that 20-some years, I spent, I think, about half of it inside of some form of manufacturing, chemical manufacturing in the form of fertilizer, supporting different business units that were all manufacturing or process control, and building products. So I've seen a lot of these things that people are talking about, and I'm looking forward to sharing some of my experiences today. Thank you, Guile.
Thanks, Michael. We thought we would start with a real-world example of some of the manufacturing risks out there. And Mike has firsthand experience with this type of thing. So, Mike, why don't you take the slide?
Yeah, absolutely. So what this slide is going to represent is a real-world example of WannaCry moving through a flat network. First thing about manufacturing is their networks are typically very old. They have legacy components, and they're not able to upgrade and patch readily. It is a constant struggle. And, you can do as much damage with patching or interrupting a process as even a malware could do. So you have to be very careful with these types of environments. But the fact of the matter is that a lot of them get left vulnerable to even rudimentary or simple forms of malware. Even old malware becomes new again in the manufacturing environment because maybe signatures have dropped out of antivirus. A lot of these devices aren't able to run antivirus or run agents, so they have limited protection. So it's very easy for malware to get that initial access. In this case, we're talking about WannaCry. So WannaCry used the Eternal Blue vulnerability, where it could, using SMB, it could inject commands, and it could do things like, in the example of WannaCry, it could get a foothold and then encrypt your files. So what happens is usually a contractor will ignore standard operating procedure for a plant, and they will need to get something into the process network. So they'll bring their laptop, a thumb drive, and those things, again, contractors and vendors, I'm not bashing on them, but they touch a lot of different manufacturing environments every day, every week, every month. And so there's lots of possibility for them to get some sort of infection. So lack of that cyber hygiene. They're going from place to place to place. They come in, they put their laptop on the network. And in my previous case, that was able to move through the network very quickly through those legacy devices. It is so fast for these unprotected devices that you literally start playing whack-a-mole. So you get that initial access, it's going to start moving through the network at just as fast as it can. And this is going to start impacting operations in a few different ways. Even if this malware can't make it out to the internet to basically detonate, what you're going to have is lots of old machines. Think XP. I've even seen an asset that had a sticker that said Y2K ready, and it was still in production. So these assets are sitting there, extremely vulnerable. They get infected, And because they were built a long time ago, they were only built to run one specific program. Usually that the malware will impact its performance. And in these types of low latency environments, if you were to basically tip over the box, right? You use too much CPU, you use too much RAM, because that's what the malware is going to do. It wasn't designed to care about the other resources on the box. You're going to start getting failures in your process just off of that. So again, the malware is going to propagate. It's going to move laterally. It's going to get all the connected boxes that it possibly can. It's very difficult to contain once it starts to spread. And finally, it's going to impact OT systems, possibly IT systems, depending on how networks are segmented. And remember, again, manufacturing usually has poorly segmented networks historically. They were built more for availability. They needed it to work, and they needed it to work very fast. So that's also a great mechanism for malware to spread. But all this being said, that OT IT convergence, folks are trying to use more IT based tools in the OT environment. They're trying to segment away this risk, and that's a good first step. So in this case, basically the malware moved through my environment. It was absolutely trying to beacon. It was causing process disruptions. And if you ever want to find out where your network is flat, WannaCry will do that for you. It'll tell you exactly where it is, because you'll watch it propagate through that network. And in my experience, it was a poor event for the vendor too, right? Because we have to work with these folks. A lot of vendors are small mom and pop shops dealing with very large companies. They're the only people who do what they do. Of course, that's not all of them. There are also a lot of big boys out there too. But they basically are going to have to take out on their insurance policy, their cyber policy, and say that they've infected a customer. And, that is a relationship that isn't really conducive to business. So all this being said, this is an example of that real world attack with WannaCry. I've lived through it. You're going to play whack-a-mole. And there are still lots of machines and assets vulnerable to WannaCry, surprisingly, even though the patch has been out since, I think, 2017. So, looking for more questions later on. But Guile, I believe, over to you.
So what is motivating cyber attacks in manufacturing? It's not just about money. A recent Deloitte survey of C-suite executives in manufacturing found that intellectual property was one of their largest concerns. And that is motivating a lot of cyber threats, as well as ransomware. And then there's downtime intolerance. Manufacturers do everything they can to stay up and running, because research shows even an hour of downtime can cost you $260,000. And then there's the critical infrastructure status. Manufacturers are responsible for more than just making products. They're responsible for the safety and the security of their communities as well. And whether that's a refinery, a water treatment facility, even an automotive company, their status in the community grabs the attention of threat actors. And these threat actors are finding ways that they're motivated to find vulnerabilities and to use it as leverage. So manufacturing is the #1 targeted sector in the industrial world for threat actors. The average cost of a data breach in 2023 was $4.7 million. And you don't have to look very far in the news to see what's going on. And hundreds of productions have been shut down to ransomware in the past year, including Clorox and Johnson Controls, to name just a few. And 45% of these attacks involved stolen credentials. And that's what we do best. Stolen credentials that were accessed illegitimately through brute force or even other techniques.
And Gal, the funny thing about mentioning those large companies, those are companies with large security budgets too, right? They were probably doing a lot of things right.
Yes.
Yeah. So, the risks in manufacturing, right? So Guy was talking about how, threat actors are highly incentivized to attack manufacturing. And this risk is growing because there is a reward, either if you're talking about nation states who want the intellectual property, or just the fact that they want to watch something burn, right? They know that if we're being attacked by another nation state, Americans pride themselves on being able to function, being able to move about their daily lives, and a cyber attack, a cyber physical attack on any of these things will produce a response, not a negative response inside of our culture. So you're talking about things like supply chain attacks. We saw that with SolarWinds. They're getting extremely crafty on how they can enter a network. We need to get more information into the process and out of the process. If you think about the products that are being produced, the metadata surrounding them, the description of how the product was produced is almost as important as the product itself. And what I mean by that is, if you're producing a building product or a pharmaceutical drug or anything used in food and bev, you need to have information that says when it was created, how it was created, what chemicals were used, what process was used. And this information starts to grow, and you need a way to analyze it, store it. And that means you're going to have to pierce that process network to get data in and get data out, so you can have more advanced process control. So that, of course, is going to increase the attack surface. And these solutions that we were putting together, we were kind of building the bicycle as we rode it, us being the security professionals and the folks building these networks, because the demand for this type of connectivity came very fast and sudden. But the networks had been built over years to just simply not be ready for this type of access. And so you're starting to see also, as this spills over and the IT-OT convergence happens, you're starting to see IT attacks that are leading to OT disruptions. There was a large pipeline where this was the issue, where basically they couldn't say without a doubt that malware hadn't spread into the process, and it made more sense just to sever the connection and shut down for a little bit, which again caused tons of mayhem for the East Coast here in the United States. More modern technologies are being involved in the process. So your DCS, your SCADA, all of these assets are starting to become more like IT assets. They're no longer pneumatic valves. They're no longer, turning things. There's a lot of automation that goes into these, and all those automations are digital devices usually. Now, when you're talking about third-party connectivity risk, we discussed that with that real-world attack with WannaCry. VPNs were never really designed as a security tool. They were designed to move traffic through the internet in a way that it was encrypted, right? So it's very easy to get credentials to a VPN. And we even give them to our third parties, usually, either willingly or unknowingly. So again, this is just bringing the risk up significantly and making it a very target-rich environment for things like malware and cyber attacks. Over you go.
I think the next slide was you, Mike.
Yeah, no, it is me. So this is an example of how these environments are kind of put together. You can see there's lots of different devices. This is kind of broken out Purdue-esque. And I think what this slide really is talking about is that flat network. Even though you have firewalls in between a lot of these network segments, and people were trying to do the best they could to segment these using that layer 3 firewall, the problem is that you still needed to get to devices. I mean, COVID showed that basically when you start getting people out of the factories and the process engineers out, and they're now able to operate these devices and get into the process from the comfort of their home, you've got to start finding ways to keep the bad guys out, because you basically created a new way in. That means that you're going to punch holes in firewalls, right? You've got to allow this access through, and it is always a dance. I had a mentor who would always tell me security and convenience are never seen holding hands, but the users need that convenience. They need the ability to get in and operate these environments. And so you see here, basically, this is just what I would consider a typical network. You got stuff going down in the process. We'll just say everything below Purdue model layer 3 down, right? You got things that control the process. You got your DMZ, maybe you got a patching server. All of these things have to get through firewalls to do their job appropriately and have some sort of back access, as well as remote access. And you also known here, or see here, I've brought in one of my best friends, sarcastic of course, the EWAN. And in an effort to support the process, these vendors need a way to ingress. And sometimes they don't even tell the customers. They just build in this backdoor VPN, commonly called an EWAN, into the process environment. And it's so they can get to their devices that they manage on the customer's floor. So if you notice, the slide looks kind of naked. You don't see a lot of protection going on there except for the firewalls. And this is true. A lot of things in layer 3 or below could not use antivirus. They couldn't use the typical ways that we were used to protecting an environment. So I'm going to fast forward, and here now we're talking about Zage and how Zage Fabric is going to further segment these devices from each other. We have a policy enforcement point. We call it a ZEP, and this ZEP is able to marry identity and network traffic, where we can perform a lot of prevention based off of just things like, for example, your way into the network, right? You've got to come through Zage. You have to identify yourself. You have to use multi-factor authentication. It's all logged. These are all really good things, not only for security, but it's enabling operations. We're giving them a smooth, frictionless way in that they're already used to being able to see. You notice that I have basically a Zage emblem in between the internet and the private cloud. And what this is saying is that there's usually things that need to happen outside of the premise of the manufacturing plant. So think the private cloud, where maybe we're doing some data storage. Think having to travel digitally through the internet to somebody else's cloud to get access to data and things like that. Zage is able to help folks in the IT side of the house as well, with things like secure remote access and getting into those private enclaves and clouds, as well as all the way down here into the process. Those ZEPs I was talking about, they will restrict lateral movement, and they also define, I call them demarcations for a blast radius. So if you see this padlock here, what I'm saying is that this is as far as it's going to go, whatever is detonating. So again, if we're talking about like this backdoor VPN, basically the EWAN, what we're saying is that customer and the vendor are now connected from a network perspective. So if there's malware on the vendor's network, there's malware right here too, because it should be very easy to traverse. This is also a very easy way to get ingress. You can purchase credentials, valid credentials, off the dark web very inexpensively. So there's lots of automation on the hacker side too, to be able to run through those credentials and figure out what works. So Zage is, if you look at something like the MITRE ATT&CK framework for ICS, we're about 90% mapped or 90% effective, and that all comes from our zero trust principles and the way we are micro-segmenting. We are using identity at the center of all of the ways that we create policy, and that's not just for humans. These devices also have identity in Zage, which allows us to even act as a separate directory when we're talking about, how do you get field devices, OT devices into a directory that you can reference and build policy around. Zage can also help with that. So we're eliminating things like that VPN access. We're really making it so your blast radius is clearly defined. So if you need to report something to the government, or just even as a security professional, need to see where connectivity is, you can get a very good picture of that. And also, again, we talked a lot about malware and things like that, but there's a lot of internal risk just with humans. Humans make mistakes, accidents. And so one of the neat things about Sage is that inside of our fabric, you get a menu that's based off of your roles that was created ahead of time. So for example, if you're supposed to be programming this PLC and not another PLC, you can only see the PLC that you're supposed to be programming. So the old fat finger of 192, 168, 1.11 and 1.111 isn't going to happen, because that's not going to be inside of your menu. So there's lots of ways that Zage is reducing the risk and making it very difficult for a malicious actor or a malicious program to move and propagate through a network, as well as shoring up and making sure that the blast radius in the event that something does happen is confined and very knowable.
Whoops.
Sorry, go.
No problem. So I think the summary here, what Mike is talking about is the Zage platform delivers both a ZTNA and a privileged access management solution. We believe that user to machine control is the primary way of enabling zero trust principles of least privilege. Users can only access machines if they're explicitly allowed to. That's the safest way to do this. And everything else is just denied by default. So if a user's credentials are compromised, an attacker will only have limited access. That's that blast radius that we want to limit as the purpose of least privilege, right? Then there's the machine-to-machine control, or microsegmentation is what Mike talked about. And we can stop attackers or malware from moving laterally, stopping them from achieving the scale of access they need to succeed in any type of attack, and making it harder to achieve the objective of the attack, right? And then there's the user to application control, which limits the ability of the user to access applications other than what they are explicitly allowed to do. One of the most common attack vectors against OT is exploitation of public-facing applications. So by denying access, by default, unless explicitly allowed by the fabric, operators can reduce their attack surface against one of the most successful attack tactics. I think we're going to show a quick video on the next slide.
We are, but Guile, you said something that makes me just kind of want to make a point. Guile, what happens when you make something hard for a human? They don't do it, right? They don't want to do it. And, you know, it's like the bear in the woods, right? You don't got to be the fastest guy. You just got to be not the slowest guy. And that's the same with taking care of your network. These guys are highly incentivized. And when I say these guys, I'm talking about the nefarious actors, the nation states, and they have a quota too. They have to get into these networks. They have to get the information they want. If you make it hard, if you make it so the old saying was attackers have to get it right once, the blue team has to get it right every step of the way. We're flipping that. We're basically saying that the attackers have to get it right every step of the way to get maybe a tiny piece of access that's going to do them no good. And that doesn't incentivize them. They want to move on to something easy. So yeah, just made me think of it. And yes, you're right. I think we're going to watch a quick video of our solution inside of the industrial environments.
Yeah, let me start that right now. Although my start button is...
Today's enterprises rely on partners, vendors, and suppliers to deliver services and maintenance for critical operational assets. Enabling these users and their application tools to access assets is a challenge. A technician might need to use a specialized application that's installed on their personal laptop to access an OT device deep inside an operational site. IT users may need to remotely access an ERP or database. Traditional VPNs and agent-based solutions provide excessively broad access and are burdensome to manage, requiring firewall rules and network configuration changes that expose your organization to risk. There's a better way. Zage provides secure remote access with granular, identity-based control all the way from the technician's machine and the application on it to the OT asset at the edge, without requiring the installation of any new clients or agents, firewall rules, or network configuration changes. For example, if you have a remote technician that needs to use FactoryTalk or ControlLogix installed on their laptop to tap into a PLC in your environment, Zage lets you provide access for a limited time for that specific user, limited to the specific asset they need to work on. To achieve this, Zage taps into the built-in VPN clients on Windows, Mac, or Linux machines, then adds a layer of granular control and security by forming a Zage Zero Trust containment point. This security overlay provides both Zero Trust access and asset protection. The supervisor or Zage administrator can terminate the session at any time and the user will no longer have access to any assets after their access duration runs out or their session is terminated. All activity is logged so that any errors or suspicious activity can be easily reviewed immediately and logged to a SIM for later investigation as needed. Zage delivers access while still protecting your assets with granular control, so you can tap into remote workers and third-party expertise without compromising on asset protection.
Okay, Jamie.
Makes me want to go hard hat and boots, Kyle, seeing all the manufacturing floors.
I don't miss wearing the boots, but the hard hat's not so bad. Jamie, any questions in the chat?
Yes, we do. We have one from NJ. They ask, as mentioned, knowingly and unknowingly, we need to provide VPN access to third party. What measures or additional layer of security shall be implemented to prevent from cyber attacks?
Yeah, no, that's a great question, and that's where that Zage enforcement point from our product really helps. And the other thing is, you know, outside vendors, they're looking for access. That's it, right? I mean, getting access is easy, or giving access is easy. Giving it securely is the difficult part. But make sure that you have a solution that is thinking about all of the other consequences and things that go with access. So, for example, what I'm referring to is give your vendor an easy way to get to your process in a secure manner, and they'll be less incentivized to have to deploy that type of VPN or E1, as well as if they are just dead set and they have to have it, segment that risk off of your network. Use a device like our ZEP, segment that risk off of your network, and make sure that that is the end of the blast radius, right? That anything that they do on that machine, I typically see them dual nicked, dual homed, but make sure that that's the demarcation for your vendor. That would be how I would solve it. Great question. Any others?
Yeah, we didn't have any more questions.
Great.
Okay.
Yeah, and so with that, I think we can close out. I would just encourage any of our viewers live or on demand to go to zage.com for any more information, or zage.com/demo on demand to see our product live. So with that, Guile or Mike, if you have anything else to add, please do.
Everybody have a great afternoon. Thanks for joining us.
Yeah, thank you for joining us. Please reach out if we can help or talk shop.
Yep. Thank you.
Thanks, everyone.
Thank you.